Okay, in the previous video, which is part 2 of this series, we worked out the Taylor series of this function, and it was centered at z0 equal to negative I on 2. The way we worked this out was by using repeated differentiations of this function here. In this video, we're going to do the same series in part B here, which we're going to explain in a moment. And this time, we're not going to use repeated differentiations. We're going to use the more efficient approach of employing the geometric series result. Okay, so in this video, the question says find the Taylor series of this function. Instead of giving us the point at which the series is centered, they are specifying the powers in terms of which the series must be. Now, in each, whenever this is done, the way to find the center is by always taking one of these and equating it to 0 and solving. So for instance, part B, if you take this and equate it to 0 and solve, you get that z is negative I on 2. So that means this question is the same or equivalent as a question that says expand these, find the Taylor series of this centered at minus I on 2, or about minus I on 2. And of course this one, if you take this and equate it to 0 and solve, this means this for this one, series is centered at the origin. All right, so let's get on with the first one. So we have got f of z equal to 2 over 2z minus I. Just a reminder, so the geometric series result says 1 over 1 minus w is the summation of w to the power n. N goes from 0 to infinity, and the region of convergence for this series is the unit disk centered at w, at the origin in terms of w. So what we're going to do is we're going to seek to write this fraction in this form, and then we simply employ that result. All right, so we have got f of z equals to 2 over 2z minus I. So the first thing I want to do is we are going to switch the terms in the denominator, and then after that we're going to factor out I in the denominator. Then now denominator is going to be 1 minus 2z over I. And so this is now in the same form as this, where w is 2z over I. So then straight away we can now write this as summation of 2z over I to the power n. Now it is a good practice to always just specify the region of convergence as soon as we do this. So here is going to be magnitude of 2z over I is less than 1, because that is our w. Okay, we're going to come back to this one in a moment. Let's just simplify the expression. So we've got here negative 2 over I into the summation of 2 over I to the power n z to the power n. and then you can see that we have got like terms in terms of this and this. So we're just going to bring those together. So we're going to have negative 2 over I to the power n plus 1 z to the power n. And so that is going to be our Taylor series of f centered at the origin. In fact, it's just the Maclaurin series. Now, in terms of the region of convergence, I'm going to do this in two ways. The first method, we're going to use this result, of course, and then the second method, we're going to do some geometric considerations. Now, I think it's always a good idea just to do both methods and to confirm that they give you the same thing. Then that should give you some confidence, comfort that your answer is indeed good. Right, so here magnitude of I is 1, magnitude of 2 is 2. So this gives us mod z is less than 1/2. Okay, so this is saying this sequence is going to be convergent inside a disk of radius 1/2 centered at the origin. So remember this series is centered at the origin, and then the radius of this is going to be 1/2. So that's what this equation is giving us. Now, geometrical considerations. The series is centered at the origin, so that's the center. Then the closest singularity of this function happens when the denominator is 0. The denominator is 0 at z equals to I on 2. So that means we've got I on 2 there. So this is going to be our radius of convergence, from which again we get a disk of radius 1/2, which agrees with this one. So then that is going to be our region of convergence. All right, then in part B, we want the Taylor series of the same function, but this time we want it in powers of z plus 1/2. We've already mentioned that this is the same as saying the series is going to be centered, sorry, this is I on 2 at negative I on 2. Okay, so how does this work? So again, we're not using the approach of repeated differentiations. So what we're going to do, what we do in this case, is we introduce a new variable u, which is equal to z plus I over 2. Okay, so this is equivalent to transforming the origin, so that the origin is now going to be at z plus I on 2, and then we're just going to find a Maclaurin series in terms of u. Okay, so if I can just make a sketch of this. So there is minus I on 2. This is the z plane. So what we're doing in terms of this transformation is introducing a u plane in the U-plane, it's going to look like this, where the origin is now going to be at minus I on 2, which you get by equating this to 0. So this is the pink is going to be your U-plane, and the red is the Z-plane. So what we need to do is to write this in terms of U. Okay, so from here, Z is equal to U minus I on 2. So when we take this and we're going to plug it in here, so F of U is going to be 2 over 2 into U minus I on 2 minus I. So minus I here. And so this is going to be 2 over 2U minus I minus I. So this is 2 over 2U minus 2I. And 2 is common everywhere. So it's the same as 1 over U minus I. Then again, we want to put this in the form 1 over 1 minus W. So what we need to do here is to factor out negative I in the denominator. So 1 over negative I. Then the denominator is now going to be 1 minus U over I. So that means this is our W. So we're going to have minus 1 over I summation of U over I to the power n. N ranges from 0 to infinity. So then straight away this is going to be convergent whenever magnitude of U over I is less than 1. So this is going to be minus 1 over I U to the power n, I to the power n. Then multiplying the I in. In fact, we're going to do that and also express U in terms of Z now. So remember, U is Z plus I. So this is Z. So Z plus I on 2. And then in the denominator, there's going to be I to the power n plus 1. Which you may recognize is exactly the same series that we obtained in the part 2 video, but using repeated differentiations. Then we are now going to come back to the issue of the region of convergence. So we have got magnitude of U over I is less than 1. Magnitude of I is 1. So this is simply magnitude of U is less than 1. In terms of Z, U is Z plus I on 2. So this is a disk of radius 1. It is centered at negative I. So if this is negative I over 2, and that's I over 2, so our disk is going to look something like this. So that's going to be our region of convergence. In terms of geometric considerations again, this series is centered at negative I on 2. The closest singularity is at I on 2. So that is in agreement as well. All right, so now we're going to give you a chance to have a go at something similar. So here, if you want to work with f of z equals to 1 over 5 plus 2z, you are going to find the Taylor series of this in powers of z in the first instance. In the second instance, you're going to find the Taylor series of this in powers of z minus 1/2. So pretty similar to what we just did. So if you just want to pause the video, work through this, and then when you continue the video, you can compare with our solutions. All right, we're now going to scroll down to our solutions for the Taylor series of this function here. First in powers of z and then in powers of z minus 1/2. We would like to thank you for visiting our channel and watching this video. We do hope that the videos are useful. We do of course ask you to subscribe to our channel to support the work that we do so that we can produce more material like this. If you've got any questions or any comments, would be happy to hear from you. Just post them in the comment section below. So the first thing for this in powers of z, what I want to do is to express this in the form 1 over 1 minus w. So the first thing is to factor out 5 here. Then of course if we insert a minus here, then that shows us that our w is negative 2z over 5. So this is going to be our summation, and then straight away this is magnitude of w is less than 1. So we'll just leave it here for now, but it's always a good idea just to write it immediately. We'll go from this step to that one. Then simplifying this is going to give us negative 2z to the power n over 5 to the power n plus 1. So that is our Taylor series. Then for the region of convergence, so here magnitude of negative 2 over 5 is just 2 over 5. Take it to the other side. So this is just a disk of radius 5 centered at the origin like shown here. Now in terms of the geometric considerations, this series is centered at the origin. The closest singularity is when this is 0, and that's going to be at z is negative 5 on 2. And so this radius here is 5 on 2, and this is in agreement with this one. For part B, we are now centered at z equals to 1/2. So let u be equal to z minus 1/2. Then expressing f in terms of u, this is a mistake here, that should be, becomes 1 over 6 plus 2u, and then we'll write this in terms of as like 1 over 1 plus w, and it turns out our w is negative u over 3, and so this is going to be our sequence. The negative half here we've absorbed into the u term, so u z minus half, so negative u is 1/2 minus z. Then from here the region of convergence is going to be the disk radius 3 centered at the origin in terms of u, and in terms of z this is centered at 1/2. So centered 1/2 here, that radius there is 3. In terms of the geometric considerations, again this time was centered 1/2. The singularity is at minus 5 on 2, and this distance is 3 as well. All right, thank you.